Hello everyone, in this video we're going to be talking about sine and cosine and how they relate to the unit circle. So first of all, let's start off, what is a unit circle? It is a circle with a radius of 1 that's centered at the origin. So if you were to graph a circle with a radius of 1 centered at the origin, you would get these points, but they would all be written as decimals, and we're going to use that in just a second. So one thing about the unit circle is that you have a horizontal and vertical displacement from each point here. So if I make a little triangle, right triangle on this point right here, okay, because there is a radius of 1, then I can do, this is the angle of 30 degrees. I can do the opposite over the hypotenuse. Okay, opposite over hypotenuse, but since the hypotenuse is 1, then this is really just going to be equal to the opposite. Remember, opposite over hypotenuse is sine, so now this value right here is going to be sine of x. Same logic here, if I go adjacent over hypotenuse, since the hypotenuse is 1, then the adjacent is just going to be equal to cosine of x. So any of the vertical distances are going to be sine, and any of the horizontal distances are going to be cosine. So what we mean by that is, on the unit circle, if we have x comma y, the x value is going to be cosine of theta, and the y value is going to be sine of theta. So let's go look at the unit circle, and we're going to be graphing sine and cosine. So first of all, sine uses the y values on the unit circle. So let's start at 0. If I go to 0 degrees on the unit circle, my y value is 0. So 0 is going to be the first value that I'm going to plot on my sine graph. Okay, here is 0. Now let's go up to 90 degrees. All right, so here's 90 degrees, and the y value at 90 degrees is 1. All right, 1. Okay, then if I go to 180 degrees, the y value is 0. And then at 270, it goes back to -1, 0, -1, and then at 360, which is back around to 0, it's going to go back to 0 here. Okay, and let's just graph maybe one other point in here. So let's graph the 45 degrees, and at 45 degrees, it is √2 over 2. So we're going to go see what √2 over 2 is equal to as a decimal, and we're going to plot that point. So √2 over 2 is equal to 0.707. So let's write this down, 0.707. Okay, so since it's equal to 0.707, it's going to be a little bit more than half here. So it's going to be about right there. Okay, so making this wave, it's going to look something like this. So let's go ahead and draw this half of the wave. And there we go. Okay, so we've drawn the right half of the wave. So let's talk about what happens if you go in the negative direction. This is positive 90 degrees, so going counterclockwise. But if you go clockwise this way, this is negative 90 degrees. So let's just go ahead and write this as negative 90 degrees. And at negative 90 degrees, it goes down to -1. Then it goes back to 0, then up to +1, and then back down to 0. So this is what the continuation of the sine wave is going to look like. Okay, something like this. And it's going to continue on forever in both directions. So let's just go graph sine of x. I want to show you guys what it looks like. Okay, here's sine of x. You can see it's going up to 1, down to -1. At pi over 2 is where it's going up to 1, which is 90 degrees. So that's just the radian value. You can see that it goes on forever in both directions. So it is going to have a domain of infinity there. All right, so let's go look at our cosine now. And instead of the y values, cosine is going to be using the x values. So let's go highlight the x values that we're going to use. Okay, we're going to use 1, 0, -1, 0, and we're going to be using this 0.707. All right, so let's start at 0 degrees, or 0 in radians. Okay, so here's 0, And at 0, it's going to have the x value of 1. So at 0, we're going to go up to 1. Then at pi over 2, or 90 degrees, it's going to go to 0. At pi, it's going to go to negative 1. At 3 pi over 2, it's going to go to 0. And at 2 pi, so all the way back around, it's going to go to 1. Okay, and then we also have this 0.707, and that's going to be at pi over 4, which is directly between pi over 2 and 0. So that's going to be right about here. So you can kind of see this wave starting to take shape. It's going to look something like this as it goes along. But I do want to go ahead and continue in the negative direction before I begin graphing. So at negative pi over 2, it's going to be 0. At negative pi, it's going to be negative 1. At negative 3 pi over 2, it's going to be 0. And at negative 2 pi, it's going to be 1. All right, so now you can kind of see this wave taking place. So let's just start right here. And here is the graph of our cosine wave. All right, and let's continue on in this direction. Okay, and like I said, this is going to continue on in both directions. So if you go graph the cosine of x wave, cosine x, you will see that it is continuing on in both directions forever. Okay, and the cosine is using the x values on the unit circle. Notice that these are almost the same graph, except that cosine is starting up at its peak, and sine is sort of starting in the middle of the wave. This is going to be important later on whenever we talk about things. So sine is starting in the middle of the wave. Cosine is either going to be at a peak or a low point. All right, hope that you guys enjoyed this video. Please stay tuned for the next one where we talk about the features of the parent functions of sine and cosine. Goodbye.